Hi friends, welcome to Bosco Campus Vision. I am Shankar Ganesh, Assistant Professor, Department of Computer Application, Don Bosco College, Kottayam. I am delighted to present a lecture on the topic data preprocessing, which comes under the subject data mining. This lecture is meant for Semester 4 and Semester 6 BCA course of Kerala University. In the previous lecture, we have discussed the types of connection. Now let's discuss different types of transmission media. The transmission media can be defined as a pathway that can transmit information from a sender to a receiver. അതായത് ഒരു സെൻഡറിൽ നിന്ന് റിസീവറിലേക്ക് ഡേറ്റയെ പാസ് ചെയ്യാൻ ഉപയോഗിക്കുന്ന പാത്തിനെ നമുക്ക് ട്രാൻസ്മിഷൻ മീഡിയ എന്ന് പറയാം. They are located below the physical layer and are controlled by the physical layer. Transmission media are also called communication channels. They differ in terms of bandwidth, delay, cost, and ease of installation and maintenance. Types of transmission media. Transmission media can be divided into two broad categories. First one, guided transmission media. Second one, unguided transmission media. Guided transmission media are also called bounded media or wired media. They comprise cables or wires through which data is transmitted. They are called guided since they provide a physical channel from the sender device to the receiver device. The signal traveling through these media are bounded by the physical limits of the medium. Guided transmission mediaയിൽ സെൻഡർ ഡിവൈസിനെയും റിസീവർ ഡിവൈസിനെയും തമ്മിൽ കണക്ട് ചെയ്യുവാൻ ഒരു പാത്ത് അല്ലെങ്കിൽ ചാനൽ ഉണ്ട്. The most popular guided media are twisted pair cable, coaxial cable, and fiber optics. First one, twisted pair cable. Twisted pair is the oldest and still most common transmission medium. It consists of two insulated copper wires typically about 1 mm thick. The wires are twisted together to reduce electrical interference from similar pairs close by. The most common application of the twisted pair is the telephone system. They can run several kilometers without amplification. But for longer distances, repeaters are needed. Twisted pairs can be used for either analog or digital transmission. The bandwidth depends on the thickness of the wire and the distance traveled. If the signal sent by the sender on one of the wires, noise and crosstalk may affect both wires and create unwanted signals. By twisting the pair, a balance is maintained. The receiver calculates the difference. Unwanted signals are cancelled out and receive no wanted signal. Twisted pair cables are of two types. First one, shielded twisted pair or STP. Second one, unshielded twisted pair or UTP. Shielded twisted pair is an insulated cable which include bundled pairs wrapped in a foil shielding. Its cost is more than UTP. In STP, outside interference is reduced by shielding. It can be used for higher frequencies, more bandwidth, and efficient signaling technique. Shielded twisted pair സാധാരണയായി ഹയർ ഫ്രീക്വൻസി സിഗ്നൽസിനെ സെൻഡ് ചെയ്യുന്നതിന് വേണ്ടിയാണ് ഉപയോഗിക്കുന്നത്. The common twisted pair cable used in communication is unshielded twisted pair. It is less expensive. The Electronic Industries Association (EIA) developed standards to classify unshielded twisted pair cable into 7 categories. Next one is coaxial cable. Coaxial cable has a central core conductor of solid or standard copper wire enclosed in an insulating sheath and an outer conductor of metal foil. Outer conductor is curved with a jacket or an insulating sheath. There are two types of coaxial cable. First one, baseband coaxial cable. The baseband coaxial cable transmits a single signal at a time. It transmits data at very good data rate and it can carry only analog signals. It can be used in conjunction with a modem. Second one, broadband coaxial cable. It can transmit many signals simultaneously at different frequencies. Next is fiber optic cable. Fiber optics are very reliable transmission channels and it transmits data in digital form. An optical fiber is a thin flexible medium capable of guiding an optical ray. Various glasses and plastics can be used to make optical fibers. It has a cylindrical shape and consists of 3 concentric sections: the core, the cladding, and the jacket. The core is the innermost section, consists of one or more thin strand or fiber made of glass or plastic. Core has a diameter of 8 to 100 micrometer. Each fiber is surrounded by its own cladding, a glass and plastic coating that has optical properties different from core. The interface between core and cladding acts as a reflector to confine light. The jacket is composed of plastic and other material laid to protect against the moisture and other environmental changes. Advantage of optical fiber cable. Optical fiber cable has much higher bandwidth compared to other media. It has low attenuation. ട്രാൻസ്മിറ്റ് ചെയ്യുന്ന സിഗ്നൽസിൻ്റെ സ്ട്രെങ്ത് കുറയുന്നതിനെയാണ് അറ്റുനേഷൻ എന്ന് പറയുന്നത്. Optical fiber cables are resistant to noise. There is less chance of damage caused by corrosive chemicals. It is much lighter than copper. They are difficult to tap, that is, it is highly secure. Now let's discuss the disadvantages of optical fiber cable. First one, the technology is not much familiar. Another disadvantage is it provides communication in one direction. Third point, it is expensive compared to other medium. The second category of transmission media is unguided transmission medium. Unguided medium transport electromagnetic waves without using a physical conductor. This communication is often referred as wireless communication. Signals are namely broadcast through free space and it is available to anyone who has a device capable of receiving them. Unguided signals can travel from source to destination in several ways. The most popular unguided media are radio waves, microwaves, and infrared. Radio waves. Radio waves are easy to generate, can travel long distances, and penetrate buildings easily. So they are widely used for communications, both indoors and outdoors. They are also omnidirectional, so the transmitter and receiver do not have to be aligned physically. The properties of radio waves are frequency dependent. At low frequencies, they pass through obstacles well. But the power falls off sharply with distance from the source. At high frequencies, radio waves tend to travel in straight line. They are also absorbed by rain. At all frequencies, they are subject to interference from motors and other electrical equipment. Due to radio's ability to travel long distance, interference between users is a problem. For this reason, all governments license the use of radio transmitters. Microwaves. Electromagnetic waves having frequency between 1 and 300 GHz are called microwaves. Microwaves are unidirectional. When an antenna transmits microwaves, they can be narrowly focused. This means the sending and receiving antenna needs to be attached. The unidirectional property has advantages because a pair of antenna can be aligned without interfering with another pair of aligned antenna. The curved nature of Earth as well as other blocking objects do not allow two short towers to communicate by using microwaves. Repeaters are often needed for long distance communication. Microwaves do not pass through buildings well. Infrared waves. Infrared waves are widely used for short-range communication. They are relatively directional, cheap, and easy to build, but do not pass through solid objects. No government license is needed to operate an infrared system. It cannot be used outdoors because the sunshades are brittle in the infrared as in visible spectrum. Example, remote control of TV and stereos. In this lecture, we have discussed the types of transmission media. Hope all of you have understood the lecture. Thank you.